Here's an example from the actual ElevenLabs website. Latency here is not just a technical metric. That is why many supposedly fast voice projects slow down later. If you answer yes to several of those questions, you are already moving away from pure buy. Let's make that voice bot concrete. Hi guys, my name is Radosław Iżak and I'm a machine learning engineer at DeepSense AI. And today I want to talk about build versus buy AI through one very practical lens, which is production voice agents. This comes from a real production project where we first shipped a custom outbound voice bot and then rebuilt a comparable version on ElevenLabs to see what got easier, what got harder, and what control we gave up. So that makes this a good case study because the workflow itself was not unusual for production voice bots. The hard part was everything around it: latency, interruptions, booking logic, handoff, testing, and stability. So the real question is not whether platforms are good or bad. It is what to build, what to buy, and what to keep hybrid once the bot has to survive in production. Because in voice, every delay is audible, every broken tool call becomes an awkward silence, and every hallucination is spoken out loud. So when I say build versus buy, what I really mean is, where do you want to own failure handling and iteration once this stops being a demo and becomes a production channel? So in this talk, first, I will set up why production voice is harder than it looks. Then I will show how a real system actually works around the model, because that is where many bad architectural decisions actually start. And from there, I will compare the build path, the buy path, using the same use case. And I will finish with a reality check, the hidden costs, the anti-patterns, and a practical recommendation. So the goal of this talk is not a neutral scorecard. The goal is a decision rule we can actually use. So what's been happening in recent years is that voice agents have become to look deceptively simple. They've become easy to demo, but are still hard to run well. A good demo can make the technology look solved. In reality, once you need reliability, latency, integrations, and real business outcomes, the problem becomes much bigger than just speech and an LLM. So this is why build versus buy matters here so much. It is not just a tooling choice. It is a decision choice about architecture, control, and long-term operational ownership. So the mistake many teams make is that they evaluate voice AI from the demo outward. So the demo shows a pleasant voice, maybe a good interruption, maybe a nice tool call, and it creates the impression that the hard part is already solved. But once you move into production, the cost structure changes. Now you care about failed calls, retries, read transcripts, and whether business users can safely change behavior without breaking the actual flow. So we should compare not just features, but the operating model each choice implies. So voice AI is one of those areas when, as I said, the demo can be very misleading, because getting the bot to sound good is no longer the hard part. The hard part is the live production environment around it. Every delay is audible, every weak transition shows up as awkward turn in the conversation, and every tool error, dropped call, hallucinated answer becomes a business problem in real time. So the 4 pressure points on this slide are the whole story in one row: latency budget, conversation control, operational stability, and business ownership. And even when you buy the platform, you still own the outcome: conversion, compliance, handoff, reporting, and failure recovery. That is why build versus buy is not just a tooling choice, but is a decision about where failure lives and who owns it. So another important detail here is that latency is cumulative. There is no single component that feels slow enough to explain the user frustration by itself. But endpointing takes some time, and so do transcriptions, routing, tool calls, synthesis, and telephony. The caller only experiences the sum. That is why teams can underestimate latency, even when every individual service looks reasonably fast on paper. So, as an example in this slide, first, the system waits to decide that the caller has finished speaking. Then it has to transcribe the utterances. Then it has to decide what to do, maybe call a tool or an API and generate some audio, and finally send that audio back through the telephony stack. Each step can look acceptable in isolation, but together they create a gap that feels unnatural. And that gap is frustrating because human conversation is built around tight turn taking. When the pause is too long, even at 1 second long, users start speaking over the bot, they repeat themselves, or they lose confidence that the system understood them. So latency here is not just a technical metric, but it directly shapes trust and perceived intelligence. So let's make that voice bot concrete. Our use case was outbound appointment booking for warm leads. On paper, it sounds narrow. Call the lead, confirm the identity, explain the offer, answer a few questions, and book a date or transfer to a human. In practice, the simple flow immediately became a systems problem. The bot had to manage interruptions, objection handling, date negotiation, booking conflicts, voicemail, and live handoff. That is why the original implementation was intentionally constrained. We kept the core path stateful and semi-deterministic, and used the LLM mainly where it added value, especially intent recognition and the free-flowing date scheduling terms. That design choice matters because it shaped the whole build versus buy comparison. So that is why I do not like also calling this a simple use case. The business goal was was narrow, but the conversational requirements were not. The agent had to confirm identity, guide the user, answer side questions, negotiate dates, recover from interruptions, detect voicemail, and transfer to a human whenever needed. There is already enough moving parts to punish a naive freeform design. So the semi-deterministic architecture was not a limitation, but it was a deliberate production choice. The case for building was mostly control. We needed deterministic behavior in the core call path, custom logic for booking and transfer, and the ability to shape analytics, observability, and handoff around the business. That matters when the requirements are specific, brittle, or expensive to get wrong in production. But the bill comes with it. The first useful prototype took several weeks, and production hardening, optimizing, and fixing issues took even more time after that. But we owned telephony, state, infrastructure, testing, and the ugly edge cases that only appeared after real calls started coming in. So my opinion here is simple. Build when the constraints are real today, not when they are hypothetical someday requirements. What we bought with custom development was the ability to shape the exact behavior of the system around the business. We could control wording, define fallbacks precisely on the deployment model, and instrument the system in the way we need it. But custom control is expensive because every capability also becomes your responsibility. So building is powerful, but only when those constraints are already real enough to justify the cost. And on the other hand, the case for buying was speed, and the speed up was real. Using ElevenLabs, a similar bot could be reproduced in days rather than months. We also saw a better out-of-the-box experience in some areas. We had more free-flowing conversations, more natural voice quality, and lower end-to-end latency when integrations did not stall the flow. Just as important, iteration became much cheaper. Logic moved into prompts, tools, and graphs, so changes were much faster to make and test. But buying did not remove expertise from the equation. Prompt design, tool schema, graph design, testing, and transcript review still mattered. No code does not mean no engineering. It means the engineering moves up one level of abstraction. However, what impressed me most about the buy path was not only the voice quality, but it was also how much organizational friction disappeared. Workflow design, prompt editing, tool setup, testing, and iteration all moved into one place. That means product and engineering can learn faster together. You can review transcripts, adjust behavior, rerun tests, and get to the next iteration much more quicker. So here's an example from the actual ElevenLabs website, where we see clearly the buy path advantage. Because if I want to recreate a meaningful bot in a custom stack, I need more than a model. I need orchestration, a workflow, representation, testing utilities, prompt management, some form of transcript review, and enough surrounding infrastructure to iterate safely. Here, much of that is already collapsed into one working surface. That is why a serious proof of concept can move from months to days. But the key message is not that the UI removes complexity. It removes setup friction. The operational questions still exist after the bot starts talking to real users. So once you frame the problem correctly, the trade-offs stop being surprising nuances. Without surprise, buy usually wins early because it compresses time to value and often gives you a stronger baseline voice experience. Build wins when control is not a nice to have, but a part of the product. Exact UX, non-standard integrations, governance, or precise failure handling. So I would not compare these approaches feature by feature. I would compare them against the operating model you actually need. If speed is the main variable, buying usually wins. If control, integration, or governance are central, building starts to make much more sense. So the practical reframing is this. Do not compare build and buy line by line, as this were a spreadsheet exercise. Compare them against the way you expect to operate the solution. If you need to learn fast, test quickly, and validate a workflow, buying is usually better. If you need to guarantee control over risky behavior, custom integrations, or control, building becomes much more attractive. So, as I said, I wanted to show a reality check for anyone who hears platform and thinks less work. Buying removes a lot of infrastructure code, and that is valuable, but the hidden cost layer does not disappear. It simply moves. You still need QA and regression testing, you still need transcript review and failure analysis, and you still need clean tool contracts, retries, fallback logic, monitoring, handoff, and incident response. In other words, the hard part shifts from plumbing to operational discipline. That is why many supposedly fast voice projects slow down later. They underestimate the work that starts after the first impressive demo. This is the part that often disappoints teams after an exciting proof of concept, because we assume that if the platform owns the infrastructure, then the hard work must be mostly finished. In reality, the hidden work simply relocates. So yes, buying removes a lot of plumbing, but it does not remove the responsibility, and that distinction is crucial. So this is also where I want to be very honest. Going fully freeform on a task-heavy flow is a bad idea. Writing vague tool descriptions is a bad idea, even when the tool is extremely simple. And trusting required tool fields to be enforced by the LLM is also a bad idea, because we saw practical versions of all these problems: skipped nodes, malformed tool inputs, hallucinated dates, fragile end-call behavior, and both weaker and stronger LLMs failing on higher risk nodes. So the better defaults are clear. Keep business-critical paths constrained. Use narrow tools with explicit schemas. Validate arguments. Spend model quality where mistakes create business harm. And regression test parts of the flow that actually matter. And that is why exactly every evaluation has to be practical. The lessons are not abstract. They are the types of failures that force you to decide where stricter control is needed. So the takeaway is quite simple. Constrain the critical path, design narrow tools, validate everything important, and spend your best models where a wrong answer creates business damage. So how should teams decide? Most people do not need a philosophical answer here. They just need a rule of thumb. So if urgency is high and the need for control is relatively low, buy. If both speed and control matter, hybrid is usually the default, although it is quite hard to implement in practice. Build becomes the right answer when control is the product, not just a preference. For example, around compliance, routing, fallback behavior, or custom integrations. And the checklist on the right is the practical version of that rule. If you answer yes to several of those questions, you are already moving away from pure buy. And one more question I would add to any decision framework is this: how reversible is the decision? Many teams look only at the speed of starting, not at the cost of changing course later. Because if your prompts, tools, transcripts, and evaluation logic analytics are all tightly coupled to one platform, then lock-in starts earlier than the contract suggests. So when you buy, try to keep your business logic and your evaluation discipline portable enough that you still have options later down the line. And if you want to build something like this yourself, start with scope, not with model shopping. Pick one business outcome, one happy path, one fallback or handoff path, and one metric that tells you whether the bot is actually useful. Then choose the voice architecture. If your top priority is the lowest possible latency, start with a speech-to-speech or real-time setup. If your priority is control over components, start with a chain pipeline where STT, reasoning, and TTS are separate. After that, design around three things immediately: tools, turn-by-turn instrumentation, and regression testing. If you do not capture per-turn latencies, transcripts, and tool traces from day one, you will not know why the system feels bad when real calls begin. So the first milestone is not a clever demo, but it is a narrow, measurable loop that you can observe and improve. And if you want to buy instead of build, the best approach is to treat the platform like an experiment before you treat it like a long-term commitment. Start with a self-serve or pay-as-you-go usage. Validate whether the bot can actually complete the task and whether the latency feels acceptable and whether your team can iterate safely. At the same time, keep the important assets portable: your prompts, your tools, your test cases, and your business logic. Then move into shadow mode or limited production rollout before you sign up for deeper commitment. The question is not just, can this platform do the job today? The question is also, how easily can you leave, extend, or externalize the risky parts if requirements change? So, when comparing alternatives, I would present them as different ownership models. ElevenLabs is very strong when you want the fastest hosted baseline and a tight platform experience. Vapi is attractive when you want more modular setup and are comfortable composing parts yourself. Rattle is relevant when the team is very focused on call operations and production voice deployment. SimFlow lowers the barrier for business-led pilots and quick experimentation. And OpenAI real-time is the route to take when the voice is becoming a strategic capability and you expect to own the architecture. So I would not ask which one is the best in general, but I would ask which one puts control, portability, and operational responsibility in the right place for your team. So my final recommendation would be staged ownership. Start by buying the agent layer when speed matters, because the gains are real, and use the platform to validate the workflow, the UX, and the conversation story quickly. Then harden the risky parts outside the platform: the tools, the monitoring, the analytics, the fallbacks, and anything you might need to extract later. And only build end-to-end when platform limits become real business blockers. The important part is to keep an exit path. If you already know you need deep control on day one, custom telephony, exact compliance behavior, bespoke analytics, and brittle edge case handling, forcing a platform fit is a pretty bad idea. The reason I recommend buying first and building selectively is that it matches how most teams learn. They usually do not need to own every layer on day one. They need to validate the workflow, the user experience, and the business case quickly. But that strategy only works if you externalize early enough. Otherwise, the platform becomes both your accelerator and your trap. So, buy to learn fast, harden the sensitive parts outside the platform, and rebuild only where the limits become real business blockers. So, let me close with the simplest version of the argument. Voice agents are not primarily a model problem. They're an operations problem disguised as a UX problem. And buy wins on speed and value and ease of iteration, build wins on control, deep customization, and precise handling. So the real build versus buy decision is not whether complexity exists, it is where you want that complexity to live. That is why the best decision is the one that matches your failure modes, not your enthusiasm. So the final takeaway I want you to remember is very simple. Complexity does not disappear. You either own more infrastructure complexity, more platform constraints, or a managed hybrid of both. That is why the right decision is the one that aligns with your operations, not the one that sounds most impressive in a demo or most elegant in architecture diagrams. And okay, that's all for today. Thanks for watching, and I'll see you next time.